A wire loop is pulled away from a current-carrying wire. Firstly, part A, what is the direction of the induced current in the loop, clockwise or counterclockwise? Several concepts that we need to invoke here. So we are dealing with magnetism. We need to think about what is the magnetic field, symbol is B, produced by both a long or infinitely long wire, and what is the magnetic field produced by a loop? Produced by straight wire and also a loop of current. We have to think about magnetic flux. We have to remember what does it mean to have an induced current, and we have to consider what Lenz's law tells us. Okay, so there are very few equations. In fact, there are no equations that we will invoke here. This is all conceptual kind of stuff. So a long or infinitely long wire carrying current will produce a magnetic field that, according to the right-hand rule, or right-hand rule number 1, the thumb points in the direction of current, and your fingers wrap around your thumb in the direction that the magnetic field would point. So that should hopefully convince you that the magnetic field would point into the page on this side of the wire and out of the page on that side of the wire. And in fact, because the magnetic field strength weakens with distance, you might even want to think about it like this: weaker, even weaker, weaker, even weaker. Okay, so that is what the wire does. And so if the wire loop is pulled away from the current carrying wire, in other words, if this is going in this direction, then the flux, which has to do with the amount of magnetic field strength and the area of the loop, the flux will go down. So that's what we have going on. Now, as a result, there will be an induced current going through this loop, and the question is, which way does it go? Before we're ready to discuss that, we should just remind ourselves what kind of magnetic field is produced by a loop of wire. So if you had a wire that had already some current flowing through it, and it looked something like this, what would the resulting magnetic field direction look like? So let's just, for sake of argument, think of it as if there is current flowing around this way, so counterclockwise. We could use our right-hand rule to figure this out. At each little segment of the circle, we would discover which way the magnetic field direction points. We would find that it points this way, it points this way, it points this way. So at least on the inside part of the circle, as drawn, the magnetic field direction is out of the page, and likewise, it would be pointing into the page on this side. Okay, so that said, we are now ready to talk about the induced current and Lenz's law. What Lenz's law says is that when there is a loop of wire with a non-zero, or let's say more accurately, a loop of wire with a changing magnetic flux, Lenz's law says that there is opposition to changing magnetic flux. That opposition it manifests itself in the form of an induced magnetic field by the loop itself that happens by or related to an induced current. So let's think about it like this. There is currently a magnetic flux in this loop of wire, and it points into the page. The loop is taken to the right, where making the flux through that loop get smaller. So the flux into the page getting smaller, the opposition to that, the opposition would be a flux into the page. In other words, it would be a magnetic field that is induced into the page. So Lenz's law would say, therefore, the induced current is the one that would give rise to that induced magnetic field. So let me draw that like this. This is the direction of the induced magnetic field as the loop is being pulled away. How do you get a loop to have a magnetic field pointing in? Well, it's not like the picture I drew. It's In fact, it's the opposite. So let me just draw this to show you what would happen if current was going around in the clockwise direction. That would, in fact, give you a magnetic field pointing into the page on the inside. That's what we want. And so the conclusion is the direction of the induced current is the same as that picture I just drew. The direction of the induced current, I induced, is clockwise, CW. And so let me draw it like this. There should be an induced current that goes around the loop in this way. Because that current would give rise to the induced magnetic field that is created in response to the changing magnetic flux. Part B, what if the wire loop stays fixed as the current decreases? Well, remember that whatever the current is in this wire, the magnetic field due to this long wire is proportional to that current. In fact, that formula, mu naught over 2 pi times I over R, the point is that the magnetic field strength grows in proportion to I. And so the present magnetic field and present magnetic flux is, again, in this scenario, going to decrease. The magnetic flux will again decreases. And so the scenario is just like part A. In response, the magnetic field that is induced would be into the page, and that means that the induced current, for the reasons we just described, is again going to be clockwise.